Today we are going to find x and y intercepts of a linear equation. If you look at a graph, the x-intercept is where the graph crosses the x-axis. So looking at this graph, you can kind of see that the x-intercept would be around here, and the y-intercept would be around here. All right. Now, could you find these without actually creating a graph? The answer after today will be yes. So to find the x-intercept, the key to remember is y is going to be 0. We're going to make a substitution. So wherever we see y in the equation, we're going to put a 0. And we'll copy the rest of our original equation down. To find the actual intercept, we'll have to solve for x. And this is just a two-step equation. We have to get rid of the lonely number first and add it to both sides. And in the end, we have to solve for x. The inverse of multiplication is division. We're left with x equaling 2/5. That means that our x-intercept is 2/5, or we could write this as the ordered pair 2/5, 0. We know this because we solved for x, because it's the x-intercept, and we assumed that y was equal to 0. Finding the y-intercept for this type of problem is a bit easier because you have your original equation, and for the y-intercept, you want to plug in x equals 0, completely the opposite. So you'll have y equals 5 times 0 minus 2. When you multiply anything times 0, it goes away. So you'll automatically have the y-intercept in an equation that's written in slope-intercept form, where you have the slope before x and the y-intercept right here. It doesn't hurt to work it out and test out plugging in 0 for x to find your y-intercept. Since we solved for y and found it to be -2, we'll put that in the y-coordinate spot and assume that the other is 0. We've now found the x and the y-intercept for this equation. We also have equations in standard form, so we need to practice doing equations like that. If we're given the equation (5x plus 10y equals 20), we can solve for both the x and the y-intercept. We can follow the same process by picking a color to find the x-intercept. We know once again that y is equal to 0. Now when we plug in 0 for y, you'll see that the y term completely goes away. 10 times 0 is 0, so we don't even need to write that. Essentially, it's like we went in and we erased the y term completely and set 5x equal to 20. For our purposes, we're going to write that back up there, but I just wanted you to see how that worked. So we still have 5x plus 10 equals 20. We're going to go ahead and finish solving this equation. If 5x is equal to 20, we have to divide both sides by 5, and we'll get x equals 4. Essentially, we deleted y from the equation completely, and we solve for x. We can do the same thing for the y-intercept by plugging in 0 for x. The same thing will happen. The x terms will cancel because 5 times 0 is just 0, and we'll be left with 10y equals 20. A one-step equation that's easy to solve. So we'll have y equals 2. The equations written in standard form are pretty simple because when you're finding the x-intercept, you're essentially covering up the y or erasing the y. So we had our 5x equals 20, and we solved and got 4. Vice versa, when we had 5x plus 10y equals 20, we're trying to solve for the y-intercept. It's like we went in and erased x, and we solved our one-step equation to get y equals 2. It's a really neat little trick that'll help you find the intercepts. Now on the ECA, they're probably going to have intercepts written as ordered pairs. So instead of x equals 4, they'll have the x-intercept as 4, 0, where we found x to be 4, and we assume y is 0. Vice versa, when we're writing the y-intercept as an ordered pair, we want to go ahead and put 2 in for the y spot and assume that x is 0. Hopefully this lesson has benefited you in learning about intercepts, and if you have any questions, feel free to ask me. Thank you.